It is hot right now. Genuinely, historically, record-breakingly hot. And if you are sitting in a room somewhere watching this, and it is uncomfortable, you probably have a fan running. Maybe you even have two. One pointed at your face, one at your chest. It feels good, right? That moving air against your skin, like the fan is pushing the heat away from you. But here is something that nobody tells you. Under the right conditions, that fan is making things worse. Not a little worse, potentially fatally worse. The thing you reach for when the temperature climbs is not helping you survive. It is speeding up the process of your body overheating. And right now, in parts of this planet, those conditions already exist. To understand why, you first need to understand what your body is actually doing when it is hot. If you ask someone how the body cools itself, most people will say sweating, and that is sort of true, but not exactly. Sweat itself does not cool you. The actual cooling mechanism is evaporation. When sweat turns from liquid into vapor on your skin, it pulls heat away from your body. That is the physics of phase change. It takes energy to turn water into vapor, and that energy comes from your body heat. So every drop of sweat that evaporates is carrying a tiny piece of your body heat with it into the air. Your body can produce up to 1 liter of sweat per hour in extreme conditions. That represents about 730 watts of cooling potential. To put that number in perspective, your body at rest generates roughly 100 watts of metabolic heat, so you have a serious cooling buffer. As long as the sweat can evaporate, you can keep your core temperature stable. But evaporation is only half the story. There is another system working beneath your skin that most people do not know about: vasodilation. When your core temperature starts to rise, your brain sends a signal to the blood vessels in your skin to expand. This is called vasodilation. It can increase blood flow to your skin by 10 to 15 times the normal rate. 90% of that increase comes from a system scientists call active vasodilation, and it is controlled by nerves that release a chemical called acetylcholine. This system is so powerful that skin blood flow can go from about 250 milliliters per minute to over 8 liters per minute. The idea is simple. Bring more blood to the surface. Let the heat escape through the skin. Your heart has to pump all that extra blood to the skin, and that takes work. On a normal day, your heart is moving about 5 liters of blood per minute. Under extreme heat stress, that number can double. Your heart rate goes up. Your cardiac output goes up. Your cardiovascular system is working as hard as it would during moderate exercise, except you are just sitting in a chair. And your body has to make a choice. It prioritizes sending blood to the skin for cooling, which means less blood goes to your muscles, your digestive system, and your internal organs. Everything else gets less. The cooling system runs at the expense of everything else your body does. Now here is where the fan enters the equation, and where things start to go wrong. A fan moves air across your skin. When the air is cooler than your body, this helps evaporation happen faster. The moving air replaces the humid layer right above your skin with fresh, dry air, allowing more sweat to turn into vapor. That is why a fan feels so good on a warm day. It accelerates your body's natural cooling system. But when the air temperature rises above your skin temperature, which is roughly 35 degrees Celsius or 95 degrees Fahrenheit, the physics flip. The moving air is no longer cooler than your body. Now, every gust of air coming off that fan is actually warmer than your skin. And when air that is warmer than your body hits your skin, instead of helping heat leave your body, it does the opposite. It pushes heat into your body through a process called convection. The fan becomes a convection heater aimed at your body. Researchers have been studying this effect for years. A 2024 study published in Science of the Total Environment confirmed that in dry heat conditions above skin temperature, fans increase convective heat gain without improving sweat evaporation. Your body loses the cooling benefit and gains the heating burden at the same time. And here is the part that should genuinely alarm you. When the air temperature is above your skin and you turn on a fan, the amount of heat being pushed into your body is not small. The convective heat gain can reach 600 to 800 watts. That is 6 to 8 times your resting metabolic heat output. Your body, which is already working hard to pump blood to the skin, is suddenly forced to manage 6 times its normal heat load while simultaneously losing its only cooling mechanism. Your heart has to push even harder. Cardiac strain increases, your blood pressure shifts, your heart rate climbs higher. And all of this happens silently, inside your body, while the fan keeps blowing hot air at your face and you keep thinking it is helping. And here is the part that makes this truly dangerous. As your core temperature keeps climbing past 39 degrees, Your body enters a cascade it cannot stop. At 40 degrees, your cells begin to cook from the inside. Proteins start to denature, which means they unfold and stop working. The lining of your intestines becomes leaky, allowing bacteria to escape into your bloodstream. Your immune system responds by flooding your body with inflammatory signals, which damages your organs further. This is heat stroke, and once it starts, it can kill you within hours, even if you are young and healthy. Now, this brings us to a number that most people have never even heard of: wet bulb temperature. Meteorologists have been measuring this problem for over 200 years using something called a wet bulb thermometer. It is almost comically simple. You take a regular thermometer, wrap its tip in a damp cloth, and expose it to the air. The water in the cloth evaporates and cools the thermometer, giving you a reading of how much evaporation the air can handle. The drier the air, the lower the wet bulb temperature. The more humid the air, the higher it goes. And when the wet bulb temperature hits a certain number, your body loses the ability to cool itself entirely. The number we need to understand is 35 degrees Celsius wet bulb. That is the threshold. At 35 degrees wet bulb, the air is so hot and so humid that sweat cannot evaporate anymore. The air is already holding as much water vapor as it can. Your sweat stops working. Your body has no way to dump heat, and your core temperature begins to rise. Heat stroke, organ failure, and eventually death. For over a decade, 35 degrees wet bulb was treated as the hard limit. But here is something that researchers only recently discovered. That number is actually the optimistic one. The PSU Heat Project, a major research study that began testing these limits on real human subjects in 2021, found that the actual survivable threshold varies from person to person and is often lower than 35 degrees. For many people, in many conditions, the fatal threshold is lower than the number we have been using as the benchmark. Now, this is also where the story of the fan gets even more strange, because the fan does not behave the same way in all conditions. In humid conditions, when the air is already full of moisture, a fan actually helps. This was confirmed by a study from the University of Sydney in 2015. The researchers tested people in hot, humid rooms, with and without a fan. In humid heat, the fan lowered both core temperature and heart rate. The moving air helped sweat evaporate even when the air itself was humid. The fan provided real physiological relief. But in dry heat, the same fan did the opposite. In hot, dry conditions, the fan increased body temperature, increased heart rate, and increased cardiac strain. On every single measure, people were worse off with the fan than without it. This is the counterintuitive truth. A fan helps you in muggy heat. A fan hurts you in dry heat. And most people have it exactly backwards, because the instinct is to think a fan always cools. A 2020 study published in Science Advances analyzed decades of weather station data and found something alarming. Episodes of extreme wet bulb heat have already occurred in South Asia, in the Persian Gulf, in parts of the American Midwest, and in the Gulf Coast. And each year the frequency of these events increases. In 2015, the Iranian city of Bandar Mashar recorded a wet bulb temperature of 34.6 degrees. That is just 0.4 of a degree below the theoretical survival limit. The air temperature was 46 degrees. The humidity was 49%. The heat index hit 73 degrees. The city came within a fraction of the threshold that climate scientists from MIT warned could make parts of the Middle East periodically uninhabitable within decades. And Bandar Mashar is not the only place. There is another city that has already crossed the line: Jacobabad, Pakistan. Jacobabad is known as one of the hottest cities on Earth. It sits in the Sindh province, a region of agricultural fields and extreme poverty. According to climate data, Jacobabad has already breached 35 degrees wet bulb temperature on at least 4 separate occasions: July 1987, June 2005, June 2010, July 2012. The threshold that scientists describe as the limit of human survivability has already been crossed in a city of 200,000 people. More than once. This is not a theoretical future. This is happening right now. These are real cities with real people, many of whom live in homes without air conditioning, many of whom rely on fans as their only defense against the heat. And the fan, in dry heat, is not helping. It is pushing more hot air against their bodies. It is increasing the heat load on hearts that are already working at their limit. The 2003 European heat wave remains the most deadly example of what happens when heat meets vulnerability. Nearly 15,000 people died in France alone that August. Across Europe, the death toll exceeded 70,000. The stories from Paris are haunting. Elderly people living alone in small apartments, often on the top floors where heat collects. Their families were on vacation, as August in France is when the entire country leaves for the coast. Neighbors did not check on them. When people returned to the city at the end of the month, some found their ceilings stained by the bodily fluids of elderly neighbors who had died and lain undiscovered for weeks. Firefighters described entering apartments that felt like ovens, and many of those apartments had fans running. In France, the highest mortality rates were in nursing homes, where the number of deaths was twice the expected rate. But the second highest risk group was elderly people living alone at home. People like Monique Taupin, a 70-year-old woman in the 13th arrondissement of Paris, who took a taxi to a hospital early in August and was never seen alive again. The 2003 heatwave killed over 70,000 people across Europe, most of them in their own homes, many of them elderly, living in apartments with no air conditioning, and many of them had fans running. The fan was the only thing they had. And in dry heat conditions, the fan was not just failing to help. It was likely making things worse. It was increasing the convective heat gain on already vulnerable bodies, pushing already stressed hearts to work even harder. And the tragedy of 2003 is not an isolated event. Climate projections show that sustained wet bulb temperatures crossing the survival threshold will happen within decades in some of the most populated regions on Earth. Parts of South Asia, home to billions of people, the Persian Gulf, the Indus River Valley, the Gulf Coast of the United States. And those are exactly the places where fans are most common and air conditioning is most scarce. In these regions, a fan is not a luxury. It is often the only defense people have against the heat. And in the conditions that are coming, that defense does not work. So, back to the fan. The reason that a fan can make you die faster is not because fans are dangerous. It is because the conditions are dangerous and the fan does not change them in the way we think it does. We assume a fan always cools because on a warm day, it does. But when the air temperature passes your skin temperature, the fan stops being a cooling device and starts being a convection heater. It is not working against the heat. It is working for it. The honest, uncomfortable truth is this. The fan in your room is not a survival tool. It is a comfort tool. And comfort and survival are not the same thing. When the air is cooler than your body, the fan helps. When the air is hotter than your body, and especially when it is dry, the fan accelerates the very thing you are trying to prevent. But next time it is hot, and right now it is very hot, and you reach for that fan, now you know what it can and cannot do, and why sometimes the thing that you reach for to save yourself is the thing that makes it worse.